Dear students, in previous lectures we have discussed about the definition of fluid flow and the manometers which are used for flow of fluid. Now we will discuss about Reynolds number. The flow of fluid through a closed channel can either be viscous or turbulent. This can be observed in classical Reynolds experiment. He discovered the nature of flow depend on the velocity, fluid physical properties, geometry of channel and pipe. Sometimes flow is even smooth, sometimes it may be uneven and rough. This all observation is conducted by Reynolds, and these observations are referred as Reynolds number. Now, in Reynolds experiment, the flow conditions are affected by four factors: average velocity, viscosity of fluid, density of liquid, and diameter of pipe. These factors are grouped into an expression as given below, that Reynolds number Re is equal to d mu rho by n. Now we will discuss in detail about this, how this equation is derived. So you just have to remember that this is the Reynolds equation, that is Re, that is Reynolds number, is equal to d mu rho divided by n. D is for the diameter of pipe, mu is for the average velocity, rho is density of liquid, n is the viscosity of fluid. So now we'll first discuss how it will affect the average velocity, then viscosity of fluid, the density of liquid, and diameter of pipe. Now first, he observed with the velocity of fluid. He investigated that fluid flow using this apparatus. This first discovered at very low water flow rate, dye did not break up, implies no mixing between the dye and water. Now he observed that in a steady state, when you insert a dye with a steady flow, dye does not mix. But at a higher water flow rate, dye did break up and dye mixed with the water. Now, what this velocity indicates that Reynolds concluded that at a low flow rate, we get streamline or laminar flow. Flow is characterized by streams that doesn't mix, that is laminar or streamline flow. At a high flow rate, we get turbulent flow and a lot of mixing. So from a flow, whenever a fluid flow from laminar to turbulent, it increases the velocity. That indicates when there is an increase in velocity, the flow will be of laminar to turbulent. Now, in case of viscosity, Reynolds observed that Reynolds heated the water. When heated, the change from laminar to turbulent occur sooner at a lower velocity. Means when you boil, as for a simple example, when you boil a water, first it is in a steady condition, but as the temperature increases, it will create a turbulence. So this is explained by the viscosity. Viscosity decreases as temperature increases. As you are aware, if a thick, let's for say example of sugar syrup, if you mix a sugar initially, it won't mix fast, but as the temperature increases and the mixing rate is higher, you are creating laminar to turbulent flow. What will it do? It decreases the viscosity. Okay, so at higher temperature, viscosity is decreased. Now in case of density, Reynolds replaced the water with liquids of different density. The change from laminar to turbulent occurs sooner for high density liquid. Now what will happen in case of density? Laminar to turbulent increases the density. There is now first in case of velocity, what will happen? Velocity is increased In case of viscosity, it will decrease, and in case of density, it will also increase. That now, in case of diameter, what will happen? Reynolds used tubes of different diameter. He discovered that as the diameter increases, the change of turbulence occurs sooner. For example, laminar to turbulent, the increase is the diameter. Now what will happen? Reynolds observed that the diameter, the average velocity and the density of liquid will increases and viscosity of fluid decreases when your fluid are from laminar to turbulence. So again the equation is referred as Re is equal to d mu rho divided by n. So again further it is referred as Reynolds number is interfacial forces divided by viscous forces. That interfacial forces are mass into acceleration of liquid flowing upon shear stress into area. The inertial forces are due to the mass and the velocity of fluid particles. Means that mass and the velocity of fluid particles are of initial forces. The viscous forces is the frictional forces due to diffuse the fluid particles. Now what will happen? Viscous forces decreases upon higher the pressure from laminar to turbulence, the viscosity will decrease, but the acceleration of fluid, that is the average velocity, density of liquid and the diameter of pipe will be in increasing position. Only the viscosity of the liquid will decrease. So this is explained by Reynolds number. Now the application of Reynolds number is, it is used to predict the nature of flow, that is viscous or turbulent, in a particular set of experimental conditions. The physical stability of suspensions or emulsion depends on the rate of settling of particles or globules. You can observe that you have performed the suspension, you have already prepared suspension in emulsion. We have shown the sedimentation of particles or the globules in the case of emulsions. So that sedimentation flow can be referred with the help of Reynolds number. But for the study of sedimentation of particle, it is referred by Stokes law. So for sedimented particles, Stokes law is used, but the sedimentation flow can be referred with the help of Reynolds number. So the rate of sedimentation of particle must not be too rapid to create turbulence. Therefore, the type of flow, whether laminar or turbulent, is important. They are heat transfer in liquids also depends on the flow, whether viscous or turbulent. So these are the application of Reynolds number. Thank you.